It's Rob here again. Hope you're all doing really well. I'm actually just before we start, I'm just feeling it a little bit today because we had our I would say an old works Christmas do last night up in Birmingham with my old colleagues from IMI Hydronics, which you can all see there, and good old Kimbo sitting in the middle. It was really good. So obviously feeling it just a little bit today, but a good time was had by all. But what I wanted to talk about today, this is part of these free tutorials that I'm doing. I'm also doing some paid tutorials, which I'll be putting up on my Academy channel. That'll be behind a paywall, unfortunately, until I can get enough subscribers, as I've mentioned a few times, and then I'll do them all for free if I can monetize it through YouTube or something along those lines. This is a basic tutorial on sizing of expansion. Now, expansion is a massive subject, and I'll be putting it behind a paywall to do a full version of it. But there's a hell of a lot to go through, so that's going to be a couple of hours, I would think, to go through on that particular tutorial. But this is just a basic way of calculating out expansion, and where people get this subject so wrong most of the time because they don't know how to set up expansion vessels or size them correctly. So I'm going to attempt to just go through this quickly and get this over to as many people as possible, hopefully. What is the the biggest causes of getting expansion wrong? Well, PRVs, so pressure relief valves. You see them on buildings dripping outside, or big stains down walls, etc., and you can tell that that's probably expansion or over pressurization of the system where it's not balanced correctly. So if we get into it, what I would state first of all, just bring up my little whiteboard here. This is to standard EN 12828 in 2014, or the VDI standard, the German standard of VDI 4708. And these are for temperatures up to 105 degrees. You always size an expansion vessel for what the potential temperature would go up to. So we're talking about lower temperature systems now, which generally needs less expansion. But expansion is quite a weird scenario. I mean, it will expand. Water will expand at 3.45% of system volume. That's from 0 degrees up to 90 degrees. So that's what you've got to kind of calculate out. So that's what it would do. So water, and it will contract at 0.79% from 40 degrees down to 5 degrees. So you can imagine you need to make sure that expansion is working correctly for the systems that you are designing. Now, there should always be a reserve of 20%. So sizing is really important, and that's part of EN 12828. So the system water reserve, you need it. So it's system water reserve times 0.05%, and that's a minimum of 3 litres that you need to go into a system. So it needs to be 20% of the actual vessel size needs to be available for water to enter it. That's really quite important. Now, if you're doing a calculation on the actual sizing of a vessel, and this is what I've been doing ever since I did my apprenticeship back in 1983, I think it was, something like when I started. The actual calculation, and this only really applies to if you're sizing commercial systems, but it's actually 0.0833 multiplied by system volume, and then plus 10%. Now, what I try to do to make the maths nice and easy, I then upsize that 0.0833 to 0.1, or 10% of your system volume, basically. And that just so if you've got a system, let's go and have a look through here at the minute. I'll just pull this one down. And if you look at this, is a design that I've just done for a client. This is a live project. I'm using one of Harry Ray's NRG zones on this one. It's a trial, but it's a hybrid system. As you can see, I've got a boiler here and a heat pump here. And of course, there's few pumps on this system now because of that, and there's certainly no motorised valves or anything like that. So it's a very open loop system. Got 3 underfloor heating circuits and a basic cylinder is set up, etc., etc. It's just on a standard SB diverter valve. So it's a very simple system. But this is the area that we want to be looking at and talking about. So we zoom into this point here. What I like to do in order to commission these properly is put a valve in front and put a pressure gauge and put a drain off in there. Now this means obviously you can remove the handle of the valve if that concerns you with the system. People shouldn't be touching valves unless they know what they're doing anyway, but that can happen. Remove the handle of a valve, but it means that what you can do is when you go to servicing this once a year, you can, instead of draining the system down or taking all the pressure off, you can just turn that valve off at that point, isolate at that point, open the drain off, and you're open to air to pre-charge your system. Now if we go on this particular system, and I spoke about before about the idea of sizing heating systems to 20 litres per kilowatt if you can. I've actually got just over, I think it's just over 400 litres in this whole system. But if we just get our calculator out and we look at, you can see I've sized here a 40 litre cylinder, so a 40 litre vessel. And if we just pull up our calculator and we can go 0.1 multiplied by 400 litres, and there you go, that's your 40 litre vessel which is going into there. That makes that quite easy. As I said, if you're talking about commercial projects or things like that, and you've got, I don't know, let's just say 200 kilowatts or something like that, you're talking a bigger expansion vessel. And this is why it then, because expansion vessels, once they start to get to a size, become quite expensive. So if we use the standard maths 0.0833 multiplied by 400 litres equals, that's your 33. So you can see what happens is as you get some, you still add 10% for pipework and expansion. But you can see that can make a big difference on the sizing of expansion vessels when you get to commercial sizing, if that's the case. I did mention again before that there's two things in heating systems that you cannot oversize. One is radiators and the other one is expansion vessels. And so that just bear that in mind when you're doing that. But pressurization, when this isolation valve is closed and the drain off valve is open and you are pre-charging that is called your PO pressure. So I'll go into this in a lot more detail on the page tutorial, but that's for another time, obviously. But the very important thing is that if you're filling a system, and it's just to try and make the maths easy, let's just say you're filling a system up to 1 bar, so 1 bar or 10 meters of head. If you're filling a system up to that level, it's really imperative that the expansion vessel, the PO charge, is actually charged at 0.2 bar above your static fill pressure. So if we're filling up to 1 bar, our expansion vessel needs to be PO charged to 1.2 bar, and that's it. Now, is that it? Well, obviously not, because you would only fill it to 1.2 bar if it was at the same level. Now this is all in a plant room, okay, and it's all at the same level. So that would be, we're filling to 1.5 bar in this particular system, but this is now filled to 1.7 bar of this expansion vessel at PO. Now what happens, and this is where people get it wrong, what happens if that vessel there's no room in the plant room for it, and the only place that you've got for it is either a cupboard upstairs or the loft space or something along that line. This is all at ground level in the plant room. But what if that is up above at, inside a loft space? What you then need to do, if your fill pressure is 1 bar or 10 meters, but your expansion vessel is in the loft space, you've got to measure the height of that expansion vessel from where your fill point is. So wherever you see this fill point in here, let's just zoom in again. This is just a little Stuart Turner SPU 130. They're very, very good as auto filler units, but they're a bit loud. That's a bit noisy. But literally, if that's your fill level and you're filling to 1 bar, for argument's sake, and your expansion vessel is in the loft space, you'd measure it up, and let's just say it's, I don't know, 6 meters above that area. What you then have to do is subtract that 6 meters from your 1 bar. So if you've got 1 bar, which is 10 meters, obviously 10, minus 6 meters, because it's going to be up in there, obviously leaves at 4. So that would be, if the expansion vessel, you're still filling to 1 bar, but the expansion vessel is actually in the loft space 6 meters above. So you say 1 bar minus your 6 is 0.4 bar, but then you've got to add on your 0.2 bar above your static fill pressure. 4 or 0.4 bar, which is your PO pressure, plus, so you've got your 0.2 bar, and then what you do is you add that on, so it would be plus 2, and that just gives you the 0.6 bar. So you, in the loft space, this expansion vessel would be charged to 0.6 bar when your fill pressure at static level is 1 bar. Because that then allows the expansion of what we said earlier on of 20% or minimum 3 litres going into that expansion vessel. For that, that's a minimum. So as I say, you can't oversize these, but getting that charge pressure correct is going to save your pressure relief valves going, your over pressurization of the system, or, which is the real killer of heating systems, if it's not charged correctly, oxygen ingress. Once you start getting oxygen ingress within a system, it will kill the system. And this is why, vacuum degassers, etc., like this little Servotec Mini here, that's why I install them on quite a lot of systems. Or there are, many other ways of maintaining and getting water quality up to VDI 2035 standards. But again, that's a tutorial for another time. But I hope you found this short video interesting. I hope it helps you size expansion vessels correctly, and more importantly, charging them to the right charge, right PO charge before you set up and before you fill up the system. So if you did like the video, please give it a thumbs up, and hopefully you can subscribe. I say if I can get over, I think it's over 500 subscribers, and I need about 4,000 hours of viewing, I can then monetize the channel, and I will be giving away all these things for free. So bless you, thank you for watching, and I will see you again. Many thanks.